Hello guys, this is Prime Concept. You're welcome once again to my channel. If you're meeting me for the first time, this is a place where you'll be learning very important and powerful concepts in physics, chemistry and mathematics. So do well to check my channel. You'll get so many videos that will help you learn physics and maths and chemistry. Now let's quickly look at this problem under uniformly accelerated motion. We have started studying graphical illustration. In my previous video, I did a background explanation, detailed explanation on the graphical illustration. So do well to check it. Now let's apply what we have learned to solve this problem. Now the question says, the diagram below shows a velocity time graph, which is this, representing motion of a car. Find the total distance covered during the acceleration and retardation. Take note of what the question is asking. They don't want us to find the total distance of this journey. They just want us to find the distance during the acceleration. This space is the space for acceleration, and then this space is the space for retardation. So they want us to find the distance in this space, and add them up. So this would be different from if the question wants you to find the total distance. So I'm going to explain the first one. So they want us to find the total distance covered during the acceleration and during the retardation. So let's find the distance during acceleration. Distance during acceleration, I'll write it as SA, is going to simply be the area of this acceleration region, which is going to be, this is a triangle like you can see. This acceleration region is a triangle, which is going to be half base, and the base is what? The base is this length, which is 10. Half base times the height is this, and the height is what? 15. So times 15. So this is going to give us 5 times 15, which is 75 meters. Now we want to also get the distance during the retardation. So distance during retardation, this is still a triangle. This is the retardation region, it's still a triangle. So it's going to be half base, and our base is this length, which is 50 minus 40, which is still 10. So 10 times the height is this is the height, which if you trace, it gives you 15 again. So this is still going to be 75 meters. Now we want to calculate the distance, the total distance. So the total distance for acceleration and retardation is going to be SA plus SR, which is 75 plus 75. And the answer becomes 150 meters. So this is what this question requires us to do. Now, another question can require you to find the total distance of this journey. It's different from this. The total distance of the journey would require you to get the area of the whole curve. And this whole graph is a trapezium. So the area of this whole graph is what will give you the total distance for the whole journey. So if you understand what to do, I want you to get the total distance for the whole journey. Drop the answer in the comment section. Let me see if the concept is clear to you. But just to help you, all you need more is just to get the area of this rectangle. This is a rectangle. This is a rectangle. So if you can find the area of this rectangle, you add it up to this answer. It gives you the total distance. Or you can decide to just find the area of the whole trapezium. You get the same result. So do it. Tell me which method you used and tell me your answer in the comment section. Thanks for watching this. I'll see you in my next video. It's Prime Concept.